Hello, hi everyone. Welcome to the Talker with Sagar. That's me, and this is gonna be a three-part technical series. So I hope you are gonna have a lot of fun. So even if you have used Talker before, you will have something to take away from here because we are gonna go right from the basics to some of the more advanced concepts of deploying your fully functional web application to a container environment in Azure. So that's going to be a lot of fun. But today, right now, the stream is mostly focused on covering the basics and the foundation that we will need in order to succeed in our deployment projects. And also, if you are interested in career in DevOps and cloud, so that's going to be super helpful for you as well. So hi everyone. Hello. Hi Mohan. We also have Hey Skitty. Hi. Hi everyone. So welcome to the stream, and let me pull up my screen. I hope you all can see my screen. Yep, I guess you all can see it. Just give me a second. Yeah, so that's about the some of the uh, background that we are going to do. So let us get started. We also have viewers. Welcome to the stream, everyone. And throughout the stream, if you have any questions, then please let me know in the comments, and I'll be able to help you out. All right, then let's get started. So, hi everyone, I am Sagar and I am a coach here at Major League Hacking. And professionally, I'm more into the world of DevOps and cloud. So, I build different DevOps solutions for our clients throughout the world and making sure that the product that they build it's properly deployed and shipped to the end users. That's what I do normally. And I'm also super excited to start my master's degree at Technical University of Munich. So this winter, I'll be there soon, and I'm super excited for that. If you want to connect with me personally, then I'm more active on Twitter and Instagram, and you can find my handle in the slides. So I'd be more than happy to connect with you all personally as well. And once again, I am happy to welcome you all to the Container Land. This is going to be a great beginning of your journey. This is going to be so much fun. And today we'll be doing the low-level basic stuffs. But as we build up into the three-part series, so in the second and third part, we are going to do a lot of other amazing stuff. So yeah, thanks for that. And yeah, please, very important information that I want to showcase you all is that please bookmark this specific link, bit.ly/docker-mls, because it has all the resources. I will also show you this in the demo, but it has most of the Docker commands as well as all the resources that we will be needing. Not only for this part of the stream, but also for the second and third part. So I'll be updating the Notion page. This is linked to a Notion page. So it will be very helpful for you to simply go to the Notion page and then just get the commands and the reference from there rather than typing it by saying it on the screen. So I have prepared this for you all to make it easier for you to follow along. So please make sure that you go ahead and make sure that you have this link on your tab. And also recommended follow-up. I would like to request you all to attend or at least watch the recording of my previous session. So I hope you all did not not all of you were there in my first session, but some of you might already have been there. So just 3 hours back, I did my stream on automating a web app deployment. So that was a MERN stack application, and I deployed it to Microsoft Azure. So we are going to use the same code base for our second and third part, not for today's stream, but for second and third part. So if you go ahead and watch the first part of the stream, then that's going to be really helpful for you all to understand the code or to just the project setup and the layout and how different things are connected with each other. So make sure to watch that recording. I have provided the link to the YouTube recording I will provide the link to the YouTube recording in the same Notion page. So make sure that you check that out after the stream. All right, so now talking about the different breakdown for this series. So in the first part that is happening right now, so we are going to talk about the introduction to containers, what they actually are and why do we need them. And we'll also talk about the popular containerization tool that is about Docker, and we'll see some of the popular and the most used Docker commands and their use cases and when to use which commands. And then we'll also see briefly about Docker networking, how different containers are set up in a Docker network environment, what are the different types of network, and what sort of communication is available for our Docker containers. We will mostly be focusing on the default bridge network. that comes out of the box. You don't need to do any type of setup. And we'll also be focusing on the custom bridge network and see how you can create your own network if you want to have that setup. Likewise, we'll also focus on Docker volumes. These allow you to have persistent storage for your Docker containers and applications. So anything that you want your containers to proceed, you need to put them in the storage, one of the storage options, and Docker volume is one of them, and demo of everything that I've just mentioned above. So that's what we are going to cover. Today, I am mostly focusing on the demo part of things because I truly believe that doing is by doing hands-on is the best way of learning. So I will be focusing a lot of the things on the demo itself. So for the second part, that's going to be tomorrow. So we will be writing our own Docker files. So instead of using the pre-built images, so right now, please uh, don't worry if you are not understanding what do you mean by Docker images or containers. I'll explain all of that in a second. But tomorrow we'll be focusing on building and writing our Docker files to build our own application images. So the Monstack application that I talked previously. So we'll have a sample repo for that, and we'll be cloning that, and we will be making sure that our application is fully containerized, and we will be pushing that containerized application into the Azure Container Registry, which is a Docker image registry. So the that will be done tomorrow itself, and we'll also learn about Docker Compose, which is an awesome tool which allows you to run multiple containers uh, at once with a lot of configuration and management options. And that's what we are going to cover in part 2. And finally, in part 3, which is also going to happen tomorrow in the later evening if you are from the Asia Pacific time zone, or it might be early in the morning for the Western folks. So in part 3, which is the final part of this series, we will see how we can actually deploy the Docker images or the containers. And we will be using a specific Azure service, which is a cloud service provider. So Azure is a cloud service provider. And if you are new to Azure, then please watch my previous session recording. I will put a link in the Notion page that I just mentioned before. So you'll get an idea of that. We'll be using the Azure Container App Service. Again, I will be covering this service from the beginning itself. So you don't need to worry a lot, even if you have not created an Azure account before. And then we will be deploying our application containers for both the front end as well as the back end into this container app environment. And then not only that, we will also set up a fully automated CI/CD pipeline. So right from the moment you push your changes or to your application repository in, let's say, GitHub, then everything will be automated using GitHub Actions. So it will build your Docker images, and then it will publish that Docker images into the Azure Container Registry, which is like Docker Hub for Azure. And then it will take that image, and then the Azure Container Apps will take that image to actually run the containers and make sure that the application is available to the end user. So that is what we are going to do, and it's a complete end-to-end technical track. So I hope that you will all stick with this track, and please watch and follow along throughout the track from part 1 to part 3. So I'm super excited for this technical track, and let us now begin. All right, so first let us understand what containers are and why do we actually need them, right? So let's take an example of an application. So let's take a front-end application or a full-stack application, let's say. So your front-end might be in React, and your, let's say, backend might be in Express.js framework using Node.js, right? So you will have different code files, your JavaScript files. You will also have the server which actually runs that code. So in this case, it could be Node.js. If you're using Python, then that could be things like Flux or Fast API. If you're using Java, that could be Spring Boot, right? So there are different servers or runtime that actually runs, or if you are using a compile-based framework, then things like language like Java, it will be compiled and then it will be executed. Then there will also be different code packages. These are the dependencies that your application needs. So if you're using external libraries, then most likely you are going to import those packages. And in case of Node.js, that's going to be npm. In Python, it's going to be the PyP packages. So things like those, right? And you will be needing those dependencies, and also you will be needing some of the functions or the core or the abilities of the operating system itself, right? So you'll also be importing some of the operating system packages provided by your own operating system. So what I mean to say here is that your application is not just code. You have a lot of other things like server, you have the dependencies, you have the OS packages. So it's a combination of a lot of things, right? So What container does is that it bundles everything. So it takes your code, it takes your dependencies, it takes the languages or the runtime environment that is needed, it takes the OS packages, and it creates a bundle. And that bundle is what we call as a container image, right? So everything is packaged into a single bundle. And the benefit of using containers is that, so once this bundle is built, we can run this bundle, or we can create an instance out of this bundle in any machine that supports Docker. So um, let's say I have a machine. We see a lot of developers, and in the world of DevOps, we also a lot of complaints goes like, it works on my machine, but it does not work on yours, right? So that's not my problem. That's what developer usually complains to the DevOps folks, right? Because and this usually happens because developers' machine are set up in a specific way, right? So they might have a different OS. Let's say the developer is using Windows operating system, and then they have the specific version of Python, and the dependencies have some specific versions. And when they committed that to GitHub, and when the DevOps folks tried to pull it and run it in the test environment, the test environment might have a Linux operating system and a different version of Python, right? And also a different version of the dependency. So, and that might create a lot of confusion, and sometimes the application does not work. So there is a lot of this dependency issues and all those things. So, to solve that, there was the birth of containers. So it bundles everything. So not only your code, but also your dependencies, your specific versions of your packages. So now you just need to build a Docker image or a container image, and then you push it to a registry, which is like a drive, or a registry, or a place where you store all your Docker container images. And then anyone who wants to use that image can simply pull the image, and then if they have Docker installed on their machine, then they can simply run that. So they don't need to have, let's say, even I could think of it in a way. So I created a Python based container images, right? So I packaged everything into my container, and then I post it, right? So anyone who wants to use my application can simply pull that. They don't even need to have Python installed on their local machine. So that's the beauty of Docker. You don't need to have any dependencies. You don't need to have any packages installed on your machine, and it will run completely fine because everything is already packaged inside the bundle. So that's the power of container image. And once we run the container, we call it as a running container. So the instance of a Docker image is a container, right? So you can think of it as a class and an object scenario. So container image is synonym, or I would say, if figuratively speaking, it is synonym to class, right? So in OOP, you have different class where you define the blueprint for your application. So container image is the blueprint for your Docker application or your application. And then once you build an image out of it and then you run it, running instance in OOP, it's object. Here, it's a container. So I hope that provides you a good background. So that is about the containers and the images. So like I said, containers turns application into one deployable artifact. So instead of having 100 files and 100 folders and 100 dependencies and whatnot, and operating system packages and runtime and XYZ, we just bundle everything into one package, and that is what we know net container image, and we can run this anywhere. We just need to make sure that the machine where the image would be running, it has proper installation of Docker. That is all that we need. And now let's try to see more about Docker, right? So please note in mind that there are different container options, right? But Docker is the one that made it the most popular. It was one of the pioneer in the world of containerization, and it is also the mostly used one. So that is why we're going to cover Docker in this series. But remember that there are other container solutions as well. Okay. So like I said, Docker is an open source. It's an open source project, and you can view the source code. You can even contribute to it if you are an open source contributor or looking into that. And also it is supported and managed by a huge community. And also if you go into production, like almost everything is a Docker based container images in most of the case. And now we have a trend of microservices, which are also based out of the container images, and then we manage it using some advanced platform or services like Kubernetes. So we don't need to look into that today, but like it's a really good time to learn Docker. That's what I all want to say. It enables developers to bundle application into containers. Containers, like I said, already existed before Docker, but Docker made it more popular, and it is nowadays a standard artifact for deploying and shipping your applications. So it is useful for the reasons that I already covered. But yeah, like to reiterate, it solves the compatibility and dependency issue, like I said, because it bundles everything into a single unit. And since you already have everything that you need in this container image itself, so next time when you want to, let's say I got myself a new machine, or I want to test my application in the server, I don't need to install my programming language or framework and XYZ, right? So I can just quickly spin up Docker, so that reduces my setup time. And you can also spin up different environments. So let's say I have my application that I want to test in my development environment. I also have a test server where I do some additional tests on my application, and also on a production server where it is actually served to the end user. So since the application is going to be the same, right? So I can just use the same image, but only configure the environment variables or change the configurations based on environment. So things like I could just change the link to the database in the prod environment versus the dev environment, but everything else is going to be the same. So I can spin up different environment properly and in a fast manner. And also installation process is different on a different on each operating systems. So rather than worrying about how I could install Python on Linux versus Python on Windows, I could just bundle it into a container and just install Docker on either Linux or Windows, and it will run the same way. So it's standardization and universalization of the app segments. All right. So as of now, if you have any questions, please let me know in the comments. And also, if you are understanding the concepts, please give me a thumbs up or give me a heads up, and I will be more than happy to carry along. So I hope this is clear for you all right now. So let us get more into the Docker architecture. Just a brief overview, right? So we have three different parts over here. So on the left-hand side, we have the client. So that's where we execute the Docker commands, right? So it's a part in our case, both the Docker host, which is the server, you can think of it as a client and server architecture. So Docker host, which is going to be managed by the Docker engine itself. So we will install Docker on our machine, and that when we do install Docker in our machine, there will be a Docker daemon which manages the Docker engine itself and handles all our requests. So that's going to be the Docker host. But we will also run the different Docker commands and tell it to do different things on our own machine. So in our case, for this demo, we have both the client and the host in the same physical machine or our PC or a laptop. But in a production environment, you could have your Docker host in one computer or one server, and you could actually connect to it and then execute the client command from a different remote a PC or a server, right? So I could have my Docker host on a server remotely, and I could execute the commands from my own PC. So that's just the layout. So when we execute different commands, we'll see the meaning of these different commands in the demo. So Docker run, which is actually used to start and run the containers, right? So that is the Docker run command. Docker build is used to build the container image. Don't worry if you do not understand the meaning of this command right now. I will explain that in second, like in some minutes. And Docker pull is used to actually pull the Docker images from the container registry. So these are the commands that we execute, and these instructions are passed to the Docker host, and specifically the Docker daemon, which is like the brain of Docker engine. And then it actually, if you are trying to pull the image, then it goes straight into the registry. So images, like I said, are the bundled artifact, right? So ultimately the code and the packages, what we bundle them together is the image, right? And we need to store that image somewhere, and that place is the Docker registry. And there are different Docker registries are available for you to use. So for code, we have GitHub repository, right? So likewise, for our files, we mostly use Google Drive, OneDrive, and all those things. For Docker images, we have Docker registries. And the most popular one and the official one is the Docker Hub repository. But we also have other registry provided by different cloud service provider, like Azure. We have Azure Container Registry. From AWS, we have the Elastic Container Registry, and things like that. So we are going to use Azure Container Registry for our demo, and we'll also pull the publicly available images from the Docker Hub registry as well. So it's going to pull the images if you don't have in our machine, and once the image is pulled, we have the images on our own local machine. And if you run the Docker run command, Docker daemon will start the images into a running container. So this is ultimately the running instance, and once it is in a container state, we can access it and use it. All right, so that was about the Docker containers. And now just a brief overview of the Docker versus the virtual machines debate. So basically virtual machines, so these are the infrastructure, that's the underlying hardware, right? The CPU, the RAM, the resources, the network devices, and all those things, those are the infrastructures. So for virtual machine, we have a hypervisor which performs the virtualizations process. And then we have like different entire different isolation of the operating system itself. So in virtual machines, we have a complete, let's say I'm spinning up three different virtual machine on my single physical hardware, right? So then I'll need to have three different operating systems. So in one virtual machine, I could have, let's say, Linux. In second, I could have Windows, and in third, I could have Red Hat Enterprise Linux, right? So I could have different operating system. I need to have different operating system. It cannot use my own operating system. So let's say I'm using Mac right now. So if I do virtualization and create virtual machines, I need to have different operating system than Mac, and I need to have like as many virtual machines I want. I need to have that many operating systems, and on top of the operating system, there will be the application that we want to run, right? So let's say in first virtual machine we run our backend, in second virtual machine we run our front end, and in third virtual machine we run the database server. So that is about the virtual machines. It's the abstraction of the hardware itself, and um, we cannot use the operating system host environment. But for the containers, the case is different. So for containers, the infrastructure is the same. So the CPU, the memory, and the resources, network resources. But the major difference here it is we utilize the resources of the host operating system itself. So here you can see that we have the Docker or the Docker engine in between. So this is the engine layer which performs the handles the different Docker process, and we run our application directly on top of our operating system, right? So Docker sits in between, but it's not a separate operating system. It utilizes the operating system that we already have. So in my Mac OS, or if you have a Windows or a Linux machine, you just run your Docker containers. Once you have your Docker engine up and running, you don't install a separate operating system for your containers. Yeah, of course, your Docker image, I'll talk about it in a later section. We'll have some binaries related to your operating system, but that's only the binaries and the processes that is required for your application to run. For things like memory management, RAM management, if your application wants to request some of the hardware resources, then all of that happens through the host operating system itself and not a separate operating system, right? So that's the major difference between virtual machines and the Dockers or the containers. And this is what allows containers to be faster than virtual machine, because you don't need to boot up operating system every time you want to start your application, right? You just have to start your operating system. The host operating system needs to be live, and then you can just start your container or stop and update whatever you want to do with your container. So that is why containers are often much faster, also lightweight, because it don't need to contain all the resources of the operating system itself. So it's much lighter and faster, scalable, and all those things. So that's why containers are it depends on cases when you want to use which one. Mostly in a production environment and in cloud service provider, what we actually do is that we take up a virtual machine, and inside a virtual machine we spin up our Docker container. So in that way we have like one virtual machine, and we have multiple apps running inside a container within the virtual machine. But that is what we do in production. All right, so I hope this is also clear for you all. All right, so now I'll just cover some of the basic commands, but this is going to be in slides right now, but don't worry, we are going to do everything by hands-on demo. So we have a container lifecycle over here. So first, the image that we build, right? So we need to have the image at first. Thanks for the compliment over there, Skiddy. Good to know that you are like my slides and Notion is being helpful to you all. All right. So first we have built. Now assume that we have already built the Docker image. I'll show you how you can actually build your own Docker image in the second part of this series. But for now, think of a public image which is already built, right? So things like take off an image of a MongoDB database, or a No or a MySQL database, or an Nginx server, or Alpine Linux, or whatever you want, right? So let us assume that the image is already built. So we first create the container. So that is the first step that we need to do. And then we need to start the containers. And once we start the container, it is in a running state, right? So it is in a running state. Or if you want to skip create and start process, you can directly run the container. So if you type docker run and then the name of the container or the image, then it will directly go into the running state without being in the created state. All right. So once the container is in running state, you can pause the container. So that will stop the current executing. If you have any processes inside your container, that will be paused. You can unpause that. You can start your container, you can stop the container, so that will free up your memory uses in your host operating system. So let's say I have 20 different containers in my host environment, so that's definitely going to use some of the memory and other CPU resources from my own PC, right? So if I don't want to use all of them and want to free up some space or the memory, then I can put them in a stop state, and I can start that whenever I want. So once it is stopped, I can also delete the container completely itself. So if I want to delete, I will use the docker rm command, and that's going to be deleted. So that's basically how a container lifecycle works. And I am going to show this all of this in a live demo. All right. So these are just the basic Docker commands, but rather than the slides, I'm going to show you in the demo. So like I said, Docker run, which will be used to create a container from an image and also start that. That will do both the things. Docker run will be used to create and start. Docker pull, if you want to pull the images from a Docker repository, so you can pull the images. Uh, yeah, yes, you have some good questions, but this will be covered in the demo. So just please stay tuned for a minute, and you will get answer to how you can get the image and create it. And just to answer your question, we can pull the image first to get the image in our own machine, and then once we pull the image, we can start the container. But if you want to build your own image for your own application, the custom application code that you have, then we need to write a Docker file and then build your application image, which will be covered in the second part. We can start pit, and then to list all the running containers, we can use Docker ps to list the containers that are in both running and stopped state. Then we can use Docker ps-a. All right. So now that was the basics of Docker. So yeah. So now let's go ahead and see some of these commands in actions. And I will show you the part of Docker networking in just a second. But first, let us go ahead and see all the basic commands in actions. So we'll come back to Docker networking in a second. But now it's time for us to actually go ahead and try all of this in real life. Okay, so let me pull up my terminal. So please open up your terminal. I hope the font size is clear. Please let me know if the font size is clear to you all or not. Is this clear to you all? Okay, I hope that you can see the font size. So right now, so the first command that I type over here, so again, for the folks who are joining late, I have provided all the commands that we're going to use in this session. Yeah, thanks for the information. So I provided all the commands that we are going to use in this session in a Notion file. So please make sure that you have access to this Notion file. I'm going to put the link here as well. So that's going to be bit.ly/mlh docker mlh docker-mlh, right? I'm going to put this in the comments as well. So make sure you get access to this. All right. So just to quickly show you what's is in there. So I have provided all the prerequisites that we need. So that is what we are going to do right now as well. So everything that we need for this session, we don't need Microsoft Azure for part 1. We will need this for part 2. And I have like mentioned all the commands that we are going to use in this particular session. So these are all the things that we'll be doing today itself. All right. So let me go back and start with the prerequisites. So you saw the error, right? So here I had a error that I cannot connect to a Docker daemon, and that is because I don't have Docker engine starting in my machine. So it has not started. And in order to start the Docker engine, we need to install Docker first in our own machine. So I have already installed it, but it is not starting because I have not started it. So for that, I need to have something called Docker Desktop, and you can download it from the link that I have mentioned in the prerequisites. So from here, you can install Docker, and I would recommend you to install using the Docker Desktop method. So if you are on a Mac or a Windows or a Linux, you can follow the instructions from here, and please download using the Docker Desktop itself and not just the Docker engine, because that's a bit complicated procedure. So if you install using the Docker Desktop method, it will be very easy for you all. So I have already installed this. If you have not, then go ahead and install this. It's pretty easy. And then I will start the Docker engine. So I need to open up my application. I'll pull this up for you all. So this is my Docker desktop environment. So you can see that the Docker desktop is already running for me. And you can see, just let me hide my, okay. So you can see that the engine is up and running, right? So the engine is already up and running. So this means that the Docker is already running. You can see if you have any running containers on this panel. If you want to see all the images that you have, so the application that is already built, right? So if you want to see all of that, then you can use the images tab and volumes, builds and everything. But rather than the GUI or the user interface, we are going to mostly use the command line interface, and that is how we do things in production as well, because we don't get the GUI interface, the GUI in servers, right? So we just have the plain Linux environment. So that is why we are going to focus over there. So now that my Docker engine is running, so please make sure that that is a very important step. You need to install Docker desktop and you need to have your Docker engine up and running. That is super important. Otherwise, the Docker commands will not work. So let me go back. Again, okay. So let me now that I have started my Docker engine. So if I do Docker PS, you can see that we do get some output. So that means that Docker is running. So I can first, let us go ahead and check the information of my Docker engine. So you can type in the Docker info command for that. And again, all of this is in the Notion guide that I have provided to you all. So it is in the Docker info. You can see that we do, like I said, Docker architecture. We have a client as well as a server, right? So you can see that we have a client over here, and then we have a server over here. And right now I have one container which is running, and then we have 7 different images, right? And you can see the different version of the server. So I'm using the 27.2 version. You can see all the other details as well, like the CPUs, how many cores I have, the amount of memory that I have for my Docker server. So it is using all the available memory space that I have. So that is going to be, and you can see that it is managed by the Docker desktop, right? And also for the client, you can see the version, you can see the context and everything. So that is, and also the different extensions of the plugins that is managed by Docker desktop. So this means that our container is running fine. So let me clear this up. Not the container, the Docker engine is running fine. So let us try some of the basic commands, right? So I said that you could run container, or you could pull the already built image, right? So let us say we want to run nginx container, right? So I will show you one thing. I will quickly pull up the repo, and then let us go to Docker Hub, right? So this is the official repo where you can find all the publicly built images. So again, for the context, images are the final artifact that is built, right? It has the application code, it has the packages, dependencies, whatever is necessary for us to run the container. And this is the official repo where it has a lot of containers for the most of the tools that you already use, right? So you can see that it has containers for nginx, which is the web server used to serve static files, also as a reverse proxy, and also a lot of web content. So we are going to use nginx for our demo as well. You can see that we already have emails for Postgres, MySQL, Mongo, Neo4j, Grafana. We have almost whatever tool that you use in your day-to-day TensorFlow, PyTorch, right? So whatever tool you might use or you might need for the publicly built images or the product, you have them in Docker Hub. So if you want to, let's say, search for nginx, I could search for here, and there might be other images as well, but please only like if you are using the popular tools, then look for the Docker official image tag, so that these are the official images, but there might also be other images built by the community members. And you can see that we have a lot of versions and tags for it. I will talk about tags in a moment. So these are the different versions. So right now the latest version is 1.27.1. So that's the latest version that we have. And even if you don't want to know the specific version by heart, you can just pull up the latest image by just typing in the name. So if you don't specify a version, then it is always going to pull up the latest image. But if you specify a tag, it's going to pull that specific tag. So you can see that we have docker pull nginx command, right? So let us try to see if we already have some images in our local container, right? So let us do docker images first. And you can see that I already have a lot of different images, right? I have Alpine, I have some of the custom images that I built. So these are not the images that you will find on Docker Hub, because these are not the public images, and I built it for my own application, and I have it locally right now. And I also have them in Azure Container Registry, which we will learn how to do it in the second part of this series. But the Alpine one is a local one, a public one, and nginx is also a public one, which is downloaded or retrieved from the Docker Hub repo. So in my case, let us try to pull the nginx image, right? Which I already have. So if I do just docker pull nginx, you can see that it is using the latest tag. So by default, like I said, if you don't specify any image, it will pull up the latest image. and you can see that the image is successfully pulled. Since I already had it, it won't pull it again. But let's say if I want to pull up a specific tag, so let's say I want to pull Docker Nginx 1.2, and again you can find the specific versions from the official documentation, right? So let's say I want to pull up I want to pull up 1.26.2, right? So that's the one that I want to pull, 1.26.2. So if I specify it in this way, so we need to provide it a colon and then the specific tag, right? So again, you can see that now it's pulling some of the different layers. So again, we'll talk about the layers. So it is not pulling this entire image at once, but actually it is divided into different layers and it is pulling it one by one. And since I already had the latest version of Docker, so some of the layers actually were matched. So the layers from version 1.26.2 and the Nginx, some of them were matched. So that is why it did not pull that image, and it was already done in just a matter of second, right? And it did not pull that. Only the layers which was not present in the latest version, so that was pulled. So that is the beauty of Docker. So if you already have an image and if you just want to make some changes and upgrade that, you don't need to build everything from scratch. It will just reuse some of the layers which has not changed. So we'll talk about this in the second part, more about the layers. So now you can see that I have pulled up the images, right? So let me clear this up and I can do Docker images again. And here you can see that now I have two different images, right? So Nginx, first one is the latest, which has the latest tech, and second one is 1.26.2, which I just downloaded. And here you can also see the ID for our image. These are our image IDs, and you can see like when this was created, since we reused some of the layers, it is providing created like 3 weeks ago and all those things. All right, so that is about the Docker images command. So now let us try to actually start a running containers, because right now if I do Docker PS, which is used to list the running container, I don't see any container. So let us try to start the container. And for that, like I said, first I could use Docker create command, or in order to avoid creating and then starting, I could just use Docker run command. And let us just run the Nginx image. So here you can see that the container is running, right? Because we are getting some of the cell outputs from inside the Nginx container. So this is actually the cell environment of container. But, right, so you can see that, okay, let me open up a new window. So you see that the Docker Nginx container is already running in one of the window, right? And I have not closed it. And if I do Docker PS here, you can see that the container is running, right? And we could see the container ID, the container name, the image that is used, also the command that is used in the entry point, and also the port where it is exported, right? So you can see that right now the Nginx container is exposed in port 80. So that is all good, and you can even verify by going to localhost and then port 80, or by port 80, since port 80 is by default, you could just type in localhost as well. So you can see that we don't get access to it. And this is a very vital question. Please remember that we are not able to access our container right now. And this is very important, because we'll learn why it is not accessible in just a moment. Please note that even though the container is running, we just checked that our container is running, right? But if we go to port 80 on our browser, we are not able to access our container. This is port 80. Port 80. I'm not, what is wrong with the autocomplete? Yeah, it's not accessible, right? So that is because of something called port binding. We will just learn about that in a second. But before that, I want to show you something. But if I just do Control C or exit from the container right now, so my container was running, right? But if I do exit, and now if I do Docker PS, you can see that the container is no longer there, because once we exit the container, it automatically stops the container. But if I do Docker PS-A, then you can see that we do have a container, but it is in an exited state, right? It is stopped 15-second echo. And we can start the container again by using Docker start command. And for starting a container, we can do it in two ways. So one, by giving it a container ID, or the second by giving it the container name. So here, since we did not provide any container name by default, it used the random name which was created when we do Docker run, right? So if you don't specify a name when you do the Docker run command, then it generates a name by itself. But if you can also give a specific name, we'll learn that as well. So if I do Docker start and then provide it the container ID, and by the way, a very cool part about Docker is that you don't need to provide the entire ID. Of course, you can as well, but even if you match some of the initial part of the container ID, it will just work. So in this case, I will do 1236. and then the container is started. And if I do docker ps, and you can see that the container is now started. So that was about Docker. But I don't want my Docker processes to be running, to I can do docker stop to stop as well. So let me do docker stop, and this time I'm going to use the name instead of the ID. So Docker has stopped that. Yeah. So now I don't have any. So Yas have pointed out that we could not access the container in port 80 because some process is already occupying port 80, and that might be the case in some of the scenario, but it is not the case in our scenario. That is because those are different ports, and I'll just talk about it in a second. Please bear with me for a second. Okay, when should we run and when should we run and start command? Okay, the run command is actually a shortcut for create and start command. So if you don't have a container, then you need to create a container first, and then you need to start the container. But you can combine those steps and you can just use docker run command, right? But let's say I want to create a MongoDB container or a MySQL, so I can do docker run, and then I could do MongoDB, or I will show you this way as well. Docker start, and then I will do MongoDB. Sorry, I don't have the local image for that. So here you can see that if I type MongoDB, it will actually search for a container which is named as MongoDB, right? But I don't have such container, so that is why it failed. But if I do docker run MongoDB, so it will try to pull the image first. So if you don't have the image, then it will pull the image. So docker run will actually pull the image from the Docker Hub repository. So pull access is denied. Okay, I don't know why. This is a strange issue. Okay, repository does not exist because I guess I might have to use some other Docker Hub. Mongo, I guess it's Mongo and not MongoDB. Yeah, I was right. We have to use docker pull Mongo instead of MongoDB. So let me go back to my terminal, and I could do docker run, and then I go to Mongo, right? So since it is not able to find the image locally, so it is actually pulling the image from the Docker Hub, and then once the image is pulled, it will automatically start the container itself. So run combines the pulling of the image and then actually starting it into a running state. So you can see that the image is started, and you can see that the process has also already started, right? And I can check that by going on to another terminal, and I could do docker ps, and you can see that the container is already up and running, right? So again, I will do Control C to exit from here. Okay. So that was about the container. But now you can see that whenever I do run, it automatically starts the container, right? And we can even start the container from the stop. We can use the docker stop command to stop the container, and then we can start the container which has already stopped using the start command. But I don't want I don't want to execute inside the container process or the container cells whenever I do docker run command. And in that case, we use the -d flag to run it in a detached mode. So that is what we are going to use right here. So let's go back to the terminal, and here you can see that I'm using docker run -d and nginx. So what this does is that here you can see the ID of the container, the full ID. It runs this nginx container in a background. So you can do docker ps to verify that. Docker ps, you can see that the container is running 3v9, right? So it's the same container, but now I don't gets automatically entered or bombarded with all the cells process outputs, right? It is running properly, running in the background, but I don't need to worry about the interface and all those things, right? But yeah, so that is about the detached mode. We call it as a detached mode, and we have to use the -d options. Now, what about stopping and start? I already covered, right? So you could use docker stop 3v9, right? I could just type in few characters, and I could start using 3v9. So docker start is actually used to start the containers for the images that you already have, and docker run is used to start the container for the images that you don't have, right? So it will pull the image from the Docker Hub. All right, that is about the Docker stack. We covered about the -d flag. We can remove the container as well, right? So if I want to remove, then I can use the docker rm command and then just provide it the ID or the name as well. In this time, let's go with name. So for ID, we use some of the truncating characters, but for name, it is always recommended to copy the entire name, right? So let us do docker rm, and you can see that we cannot remove it because it is already in a running state, right? So first we need to stop in order to remove. So we can do docker stop first, 3b9. So now it is stopped. So if I run the docker rm command, now the container is removed. So if I do docker ps again, you can see that it is not here as well. And even if I do docker pss, it is not here as well, right? Because that was the name using trusting Torvalds. I don't have that container anywhere over here. Okay, so that was about the docker rm command. So I hope you learned about that as well. So now let us try to see how we can run a container and give it our own name. And for that, we use the dash name flag. So here, I do have specific questions about npm package in the comment, but we will have to look into a specific part of your code in order to understand that. If I have time towards the end of the stream, then I'll definitely look into it. But for now, please stick with the session. I hope that you will get some idea about why that issue is occurring. All right. So in order to specify the name, then you can use the dash name flag, right? So here, I'm trying to run the docker run command, and this dash d, as you already know, it runs this container in the background, so you don't get bombarded into the cell of the container itself. We provided a name. So in this case, this is the name of the container. So instead of a random name, now this will be the name of your container. And finally, you provide the image. And if you want to use a specific tag, like I said, it provided with a colon and then the version of the tag version that you want to use, right? So yeah, you can do this. But for now, I'm going to use the latest image. So this is how you run a container by specifying a name. And if I do docker ps, you can see that now the name is not a random one, but a specific one, which is nginx prime in our case. So that is docker ps. We did about that. And now let us come back to the port question, right? So why was docker not accessible? And why is docker not accessible even if I go to localhost port 80, right? So I don't get any response. That is because docker runs in a completely isolated environment. All the containers that we are running, each of them runs in a separate isolated environment. So they have their own network layer, they have their own storage section, which is a temporary one if you don't use docker storage option. So they have their own temporary storage, they have their own network space, and they have completely isolated Linux processes, right? So they are like own computer or own server in itself. So that is why this port 80 here refers to the port of the container, and our operating system will have no idea about the containers that it is running, and the ports that the application inside the container is running. And same is the case for container will have no idea about what are the other containers that are running in the system or what are the other processes running outside the container. So it will only have the context of within the container, but container A will not have any idea about container B and its processes. Similarly, container B will not have any idea about container A and its processes. And that is the reason we are not able to access port 80 on our browser, because our browser, when we hit port 80, that is on a host, that is on our PC, right? But this port 80 is inside the process of the container. So that is why we are not able to access port 80. And that is why we could even run two containers to prove you the case. I will just copy this command, right? And then let's change this to npm prime 2, right? So I will create a new container. And if I do docker ps again, here you can see that we have two different containers which are using the same port, right? And you might wonder how on earth is that even possible, right? How could two different processes be running on the same port? Because actually they are not running on the same host. This is one container, that is another container. Those two are completely separate environments, so they can have the same port. And that is why we are not able to access it from outside. And that is why you need to use the dash p flag whenever you want to publish a container or you want to map a container, right? So things will be like this. So it's going to be docker run dash d, and then this is the port mapping that I was talking about. And you can see that the first port and the second port is separated by the colon, and the first port is the port on the host, which will be mapped to the port on the container. And that is super crucial. So this means that port 3000 on our host machine. So this means that there should not be any other applications or process which is occupying port 3000. It needs to be free. And this is the port in the container where the container is running. So in our case, both the container running on port 80. And then we specify the name of our container. So in this case, I will do nginx prime 3, right? And again, this is also using the nginx image. So now if I do docker ps, you can see that we do have a port binding listed under ports. So previously, these two are the nginx prime and nginx prime 2 were running separately. It did not have any connection to the host machine. But now for nginx prime 3, we do have a port mapping which is mounted from port 3000 to port 80. So this means that any request which is sent on port 3000 localhost on the host machine will be forwarded to port 80 on the container itself. And that's the genius of Docker networking. So this way, if I now go to my browser, and if I now type docker host and not port 80, remember port 80 is still not accessible, but we need to type in the port mapping of the host. So if I do localhost 3000, here you can see that we get the nginx default page, right? Yeah, so now we are able to access the container. This is being solved by the container itself, because the port 3000 on my host machine is being mapped to port 80 on the container, and that is how it works. So I hope the idea of port mapping is clear to you all. So now let us also see the command for executing inside one of the cells. So we earlier saw that even if you don't specify -d, then you will be directly executed inside the container cell, right? And you will be bombarded with the process output. So what if you want to actually go inside one of the container and see the different stuffs inside that? And for that, you use the docker exec command, and you provide is the IT flag. So this stands for interactive terminal mode. So this means that you will go inside the cell. So likewise, currently I'm in the environment of my Mac OS machine, right? So I'm in my host machine. So whatever I type in the terminal, that will be executed on the host machine. But if I want to access the cell or the terminal environment of the containers, then I can do docker exec dash IT and then the name of the container. So in this case, let us execute inside nginx prime 3, right? And then I need to provide it the path to the cell. So that will be bin. By the way, you could run any command as well, docker exec it, and I could use it to let's say touch hello.txt, right? So I could use it to do this as well. I could do a lot of different command, but right now I want to execute inside the cell. So I will do /bin and sh. So this is the link to the cell, and you can see that now I am inside the cell of the container itself. So if I do ls, you can see that these are the different binaries, Linux binaries inside the container image of nginx, right? So I could do touch hello.txt, and I could do ls. You can see that the hello.txt file was created. So all of this happens, right? So I can exit from the container using exit command. So that is how you execute inside the cell of a container. And it is mostly used for debugging purpose. You don't normally execute inside the container. We don't normally need to do that, but only in case of, let's say, checking some of the configuration files, or you want to see how your actually the image was built, then you can execute inside and access the terminal of your container itself. So that was about the container environment. And now let me clear this all. And now I will also show you the command to delete the images, because now we have one additional image. So let's say we want to delete this particular image, right? So there are different ways to do that. The command is docker rmi command, and you need to provide either the image id or the sorry, you need to provide the image id, total id itself. So you can also provide it the name, but if you provided name, then you need to provide tag as well. So you have to do docker rmi nginx and then 1.26.2. So in this way, you need to specify the repository. So in this case, it's the repository nginx, and the tag is 1.26.2. So you could do it this way, right? But you could also just rather just copy the image id and then paste it. So that is a much faster way. Since we already deleted that, we don't find any other image, but I normally prefer deleting image from the id rather than the name. All right, that is about the docker images and how we can remove the different images. I hope that all of this is clear. And that was all about the docker basic commands. So we'll now go into docker networking. So I hope this is clear. So docker run and then the name of the image that you want to run to pull the container, or you could also do docker pull. Let's say I want to pull MySQL. So it will use the default tag, right? I could pull the image in my own machine. Yeah, it's pulling the image. Depending on the size of the image, it might take some time. So this seems to be a bit heavier side. So yeah, it is downloading all the layers for the image. In the meantime, if you have any questions, please feel free to ask me in the chats. And once the image is pulled, you can see the image under the Docker images command. You can see that I have MySQL latest. So now I can do Docker start and MySQL. I don't need to provide tag if I'm using latest, right? So that is what I'm going to do. Oh, sorry, Docker start, not that, Docker run, and then MySQL, right? So I could use this, but if I want to run it in a background, I could use the dash flee flag and Docker ps. So now, oh, unfortunately, it exited. I do not know why. For that, there is one command that you can use. So for a container, let's say if you want to also check the logs of the container. So in this case, if I want to check logs, especially useful for debugging, then you can pass in the Docker logs command and then the container ID, and this will provide you some of the useful logs that you can use to debug. So let's just try to check what happened with MySQL in this case, Docker images, and then okay, Docker run and then dash t. Oh, this is because I remember this because it when you run Docker like MySQL, it also needs you also need to provide some of the additional configuration, like usually the admin, the database admin details and all those things. Like, and you can find those information in the official repo. So let us go to the official repo, and let's say for MySQL, you can see that how to use. So here you can see that you also need to provide the root password for your database admin, right? So that is why it was failing for me, because we did not provide any environment variable. So here you can see that we need to provide MySQL root password as an environment variable. So dash e flag is actually used to specify environment variable. So some of the containers might need environment variable. We will also be using environment variable in second part of our demo. So dash e is for environment variable, and then this is the key, and the value will be the actual password, right? So in normally we don't store the database password as an environment variable, but this is just for the demo purpose. That we use in production. We use different services like AWS Secrets Manager or other secret provider to actually populate or put the value of those environment variables or secrets in a runtime, and rather than exposing them in a Docker container. Because please remember that whatever you put inside Docker image will be accessible by anyone who has access to that image. So don't put any secrets or API credentials or anything that is confidential inside your Docker image. So that means that you should also not put it within your application code. Rather, you should put it during either your CI/CD build pipeline as a secret, or during the runtime as secrets as well, using different services like AWS Secrets Manager. All right, so that was about Docker simple commands. So let me just clear this up for now. And now let us go back to slides to learn a bit more about Docker networking. Okay, so before that, if I have any questions, Bhavisya has asked if there is any other challenges, or are there any challenges in this event? Not particularly in this my own stream. You can follow along. You can check out the Notion link that I have provided. It has all the resources and you can follow along. But if you want to check out the challenges for the overall Global Hack Week, then you can check out the official website of Global Hack Week, gsw.mls.io/challenges, and there you will find the information about the challenges. All right. So just let us take a quick 2 to 3 minutes break, and then I'll be back and we'll talk about Docker networking, and then also Docker volumes. Before that, I just have a quick question. Okay, this is a really, I would say, a good question. Are there any fun ways you have used Docker in your personal life? A big reason I don't do personal projects is because I can't find a way to use in my personal life. And that's exactly what we are going to cover in part 2 and 3, because we will be using Docker for our real full stack Mon application project. We will see how we can, so up until now, we are using already pre-built images, right? It is already there in the Docker Hub. So we are just pulling the images and then we are just running it, right, for our own specific need. But what if we want to build the Docker containers for our own applications? So in that case, we will need to build our own Docker images. We need to write Docker files. We need to use Docker Compose and all those things, and then we need to deploy it. And all of that is a real example of how actually Docker is used in other production environments. So imagine this way. So if you are actually running a business, or if you're trying to start actually using Docker in production environment, the scenario is like this. So you have, let's say, 10 different microservices that you have written your code yourself, right? So your application team has developed different microservices for your e-commerce application. So you have 10 different applications. So you will have the Docker container for 10 different microservices, 10 different container images, right? So you need to deploy these images to somewhere. So you will have the container registry where you will store these images, and then it will be automatically, either you will deploy it automatically using Kubernetes or some other managed container orchestration provider, right? So that is how you use in production. And at the same time, we also make use of the publicly available Docker image. So let's say my microservice also use MongoDB or MySQL or any other. Let's say for logging, I use Prometheus, which is another tool that is used for logging and metrics and all those things. So we use this publicly available external uh, tools as also as containers and also our microservice. So our microservice will be communicating with this other microservice, which are also in containers and made from the publicly available images. And that is how it is done in production. So for you all to get started, please stay tuned for part 2 and part 3, because there we will be creating the containers for our Mon application project, and then we will be actually deploying it, creating image and all those things. That's a really good question, and I hope this gives you more context on how container is actually used in real world scenario. And also you could do it for your sample projects, whether it is a Mon application, a mean stack application, fast API, whatever tech stack that you use. All right, I hope that provides you some context. So just 2 minutes or 3 minutes break, and I will be back. All right, welcome back from the short break, and let us just continue with our session. Again, if you have any questions up until now, I hope things are very clear. I just covered some of the basics of containers and how you can pull different images, how you can start, run, manage containers, you can how you can run it in a detached mode, or how you can do port bindings to make sure that your applications or containers which are exposed as a web service can be accessed from your browser and all those things. So we just covered all of that, how you can delete an image, how you can create a new container, and all those things, right? So now let us see more into uh, will we have time to review the GitHub Action session before part two? Unfortunately, not for Docker, because we will be covering that in the GitHub Actions will actually be there only until the final part. So we'll be seeing how we can automate the deployment of Docker containers in part three. But if you want to see how GitHub Action works, and if you want to see how it helps you to deploy a normal application without using Docker, then you can check out my previous stream, which you can find in the MLS YouTube channel as well. I just did that a few hours back, and there I have mentioned how GitHub Action works to actually deploy applications. But that was without using Docker. We are going to use the same one application, by the way, for the Docker demo as well in part 2 and 3. But we are not. I did not use Docker back then, because that is the agenda for this stream. I hope that helps. Okay. So Docker, like I said, every containers inside Docker are isolated by default. So by default, one container does not know what is there in the second container, or they can't communicate with each other. So that means that if I have a front end and a back end, and if I containerize both of them, then there is no way I can ask my front end to make API calls to my back end if I do not do any Docker networking, right? So there is no way they will be able to communicate uh, like by default. There is you can communicate using the default IP address that is assigned to the container, but there needs to be some sort of the networking setup. And by default nowadays, normally when you run a container, it is run in something called the breeze mode, the default breeze mode, and containers will be able to communicate by using the IP address, but not the name. I'll just talk about this in the demo. You will be more clear about that. And container has no information on what kind of network it is attached to, or whether its peers are also, even if they are Docker workloads or not, the container will have no idea about that. So if I go ahead and in my terminal and type in Docker network ls, which we will do when we have in demo, you can see that you have a lot of different networks, right? So there is something called Breeze network. There is this is AlpineNet, which is the custom network that I built. But by default, you have like Breeze network, the host network, right, and a non-network. So you can see a lot of network names over here. It does have an ID as well. And the most important thing that is over here is the driver. So what driver does it do? You can see that most of them is using the Breeze network driver, which is the focus of this session as well, which I'll talk about that. One of them is using the IP VLAN, one using the host, and the other one is using null. So now let us see what all these things are, right? So so mostly there are three different network types in Docker. And the default one is the Breeze one. So that is on the left hand side of this picture, right? So whenever you run any container that you run without specifying any network parameters, right? Ubuntu, Nginx, whatever container you run, it is run in default Breeze network by default. So even if you don't specify anything, it is always run inside one network, that is the default Breeze network. And often the name of this default Breeze network is Docker 0. So we'll check this in demo. So this is the name of our default Breeze. So every container that you run will be connected to this specific Docker 0 network, and each of the container will get one IP, right? So these are the virtual IPs that our container will get. So our device has some IP range, right? So from the router that we connect to, our device gets some IP, and inside our container, we are inside our machine, we are running multiple containers, which is managed by the Docker desktop. So those are the virtual IPs. So each of our container will also get some specific IP. So think of this Docker 0 as your router, right? So it provides specific IPs to each of the container that we run. So that is about the Docker Breeze network. If you specify dash network equal to none parameter or flag when you run the Docker command, then that container will be completely isolated from the host. So you won't be able to access the container by any chance, and it will also not be able to connect to any other container. So even so here in this case, we have different container. It was connected to the Docker 0 network, and we could do port binding side. We could do things like 3000 port map to port 80 on the container, and we could access it from port 3000. So it was still connected to host if we used port binding. But if you use host none, then that is not possible. So that means that container will run in complete isolation. It will not even be able to connect to the internet. So if your container has some processes which requires internet connection, or if it wants to make some API calls to some external third party which is over the internet, then that is also not possible at all if you use the non-network. It is used in some very specific scenarios and mostly for debugging, so not widely used. And finally, we have the host network type. So if you specify dash dash network equals to host, then that means that the container will use the same port as the host. So previously we had a case where we run nginx without specifying the port binding dash p option, right? So if we specified port, so that means that port 3000 or port 4000, you could map any port with the container port of port 80, right, for nginx, or if you are using any other service, the port of that service. But if you use docker network host option, then it will use the port on the host itself. So I don't need to specify port 80 on my port binding. So I could just use docker run dash dash network equals to host nginx, and if I open localhost on my browser, it will just work because it is using the port 80 of my host. It is not using a separate port inside a containers, and that is what is essentially about the host network type. It is also not widely used because we want our container to be running in a separate process, and we don't want it to occupy the ports in our host, because we want to keep it free for other processes. And we also want it to be communicable to other containers, right? So we mostly use the breeze network. So just to give you an overview, these are the three different network types, and a bit more detail about the breeze network. So let's say this was the host, right, and this is the external network. You can consider it as like our internet or the router that is connected to the internet, and this is your PC. So your PC will have a specific IP address. In this case, it will have an interface. So the interface usually is named as H0, so that is the default interface, but it might be different for your different operating system. And so this is the IP of your PC, of your device. So, and there you have different containers. So we have a database container and a web container. So there is the MyBreeze, which is the Breeze network, but this is a custom Breeze network. So this is not the default Breeze network. Remember that the default Breeze network is named as Docker 0. This is not the one that you create by yourself. It will automatically created by Docker itself, but MyBreeze is something that you create. You can create yourself as well. So there are two different kind of Breeze network that is very important for you to remember. One is the default Breeze network. So if you don't specify any network parameter when running container, that is run in the default Breeze network, the Docker 0 network. But if you create a new custom Breeze network, which we'll learn how to, and if you attach the container to that network, then that is the custom Breeze network. And here you can see that both the containers are connected to the MyBreeze network, and each of them will get some other virtual IPs. So in this case, it has 172.19.0.2 and 0.3 for the web container. And you can, let's say, expose the web services running on port 5000, and you can map it to port 8000 on the host. This is similar to what we did for nginx. So you have an nginx, and nginx was running on port 80, and the outside for the host where we were exposing port 3000 for that. And if you go to your browser and port 3000 localhost, it would have been able to access the nginx container. And here, if you go to port 8000, it will be able to access the web service which is running on port 5000. I hope this is clear for you all. All right, so let us now go ahead and check the demo for Docker Network before we go into Docker storage. Please note that for this first stream, these are about covering the fundamentals and the basics which are required for our part 2 and part 3, and also for your long-term career in DevOps and cloud. If you really want to master Docker, these are the solid foundations. These are the foundation knowledge that you will need. So I'm not going too deep into any of these specific topic, but I'm providing you with the enough basis to get you started and to make sure that you understand this as well. Because if I go too deep, then it might be a bit out of scope for this specific stream. All right, so let us pull my terminal back. And again, for all the commands, please follow the Notion that I have provided, right? So I have provided all the links that I've used in this session in the Notion, so you can follow that. So let us go ahead and see Docker Network in action. I hope the size of my container is still good. So if I do Docker network, right, and then ls, so this is the command that is used to list all the network that I have. So you can see that we talked about the null, right? So, and the non, so the container will be isolated. It will not be able to communicate with any other container or host or even to the internet. And then we talked about the host. So it uses the same port on the host service. So that means that that port on the host needs to be free, and we can't use the same host for same port for different containers. And then the most popular one is the breeze. So there are two different kind of breeze: the custom breeze, which is by default if you don't specify anything, but we can also create our own custom breeze network, and we'll see how in just a second. If you have any questions, just let me know in the comments. Okay, so now let's try to run another container, right? So here you can see that we are trying to run an Alpine based container. So this is the name of the image, and I'm running it in a dtask mode. You already know by now what the dash d does, right? And also dash it. So this is used to execute inside the container, right? So I want to run a container in a background mode, but I also want to attach that container to a cell, right? So this ASH is the cell for the Alpine. So earlier we did ban/bean/ss, right? So that was for the other cell. By the way, I could also do this instead of ASH. So that will also work totally fine. So yeah, I could do this as well. You can see that this container is now running. So next time when I just do docker attach, right? So if I can do docker attach Alpine1, so this command is used to attach my current terminal to the terminal of the container itself, to the process of the container itself, right? So my container is named Alpine1, right? So I could, before I do a docker attach, I will confirm that. So you can see that my container is running, right? So Alpine and then Alpine1, right? So if I do docker attach, right, so it will automatically add this command in my container, and it will take me directly inside there. So instead of every time if I do docker exec dash it and then the name of the container and /bin/sh, so instead of doing it every time, I can just specify the default command that the container will use, and then I can just attach it. So next time if I do a docker attach, it will just use this command, and now I'm directly inside the cell of the container, right? So yeah, this is what we can do. All right, so let me just exit it for now. Docker ps, you can see that the container is exited. Images and name difference. Okay, so image is what, Docker, just a second. Images and name difference, clear this out. Docker images. So if you do docker image, you can see that these are the official image. So image name is something that you give to your containers. So not to your containers, is something that we use to pull the image from the Docker Hub. So this needs to match exactly on the documentation link for your Docker Hub or any other registry that you use. If you are creating your own container, then you can give any name that you want. But if you are trying to pull in public image, then this name needs to match to the image. So in this case, Nginx, if you don't specify in tag, it will be latest. But for other images, so let's say this is our own custom image, then we can specify the tag. So that is the name of the image. Image name is one thing. And when you create a container, a random name for your container will be, that's a running instance of your application, right? So a random name will be provided, but if you can also provide a custom name for your container. So that is the difference between image and the name. So by name, by image, I mean the official image name that you use, and by name, it's normally the container name. Okay, so I hope that is clear. Thank you, yes, for the confirmation. Sorry, not Docker clear, it's clear. So we talked about Docker network ls. We talked about the different network types, right? So, and now let us try to, again, I will try to run, let's say I'll run two different containers. Okay, it's already in used. Just a second. Docker ps test a. Yeah, so the Alpine one is already in use. So let me just try to stop or even remove the Alpine one. rm Alpine one. And if you want to remove a container which is running, you can use the -f flag to forcefully remove it. So you don't need to stop and then remove the image. You can just simply remove the image as well. All right. That was Alpine one and not Alpine. All right. If the container is stopped, then Breeze will be alive. See, if the Breeze network will always be there no matter what, right? So it will be, even if you have a container in a running stop, all the containers are still connected to the same Breeze network, right? But if the container is in stopped mode, let's say you have 3 different containers and all of them is connected to the default Breeze network, and you want to access container 3 from container 1, that is not possible because the container 3 might be in stop state. So all of the containers need to be in a running state in order for the communication to happen smoothly. So the Breeze, yeah, the network will still be, the Breeze will still be there, right? But the Breeze will be in offline state because the container is also offline, right? So it needs to be online or it needs to be a started state for the networking protocols to work and exchange the data. So that, I hope that answers your question. Okay, so let us try to run two different containers. So I'm running Alpine 1 and then Alpine 2 and attaching their cell, right? So if I do in Linux, you can do ifconfig. So ifconfig. Uh, we have a question: who is running the Breeze network? Docker engine. Docker engine maintains the Breeze network by default. There is a default Breeze network, which I am going to show you right now, named as Docker 0, which even if we don't create, it will automatically be created, and that is how containers can communicate with each other and to the internet. Um, so that is defined and maintained by the Docker daemon or the Docker engine itself. So I hope that answers your question. Okay, so in Linux or Mac, you can do ifconfig. All right, so if you do this, then you can see that there are different interface, right? So you can see that there is en0. So this is the default interface for my PC. So this is actually my PC interface. You don't need to understand anything over here. Just understand the inet option. So this is actually the IP of my device right now. So this is the IP of my device. And for if you go scroll up and if you go down, there you can see that we have the Breeze 0, right? So this is equivalent to the Docker 0 for Docker desktop for Mac. So if you are using Linux, you can actually see Docker 0. For Mac, since I'm using Docker desktop for Mac, the name is Breeze 0, and this is actually the default Breeze network name that we have, right? So this is the default Breeze network name. And now that is about the ifconfig, that interface that was already created for me by Docker engine. So that is about the ifconfig. And now let us try to Docker network ls, right? And then let us try to inspect the Breeze network. So there is a command called inspect, and I can use it to get some additional detail about the network. So I could type in Breeze or also the network ID, but I'm going to type name. And here you can see that we have a lot of containers, right? So you can see all the information about the network, like when what is created, what's the scope. You can see the driver, it is the Breeze driver, right? And you can see that it has a specific IP subnet range. So all of the containers will get IP from the specific range. So this is the subnet ID, and you can see that there are like 1, 2, 3, 4, 5 containers right now, which is using the default Breeze network. So you can see that what are the containers which are attached to this network, right? So that is about the default Breeze network. You can see that the default Breeze is set to true. This means that it is a default Breeze network. So I hope that is clear to you all. And now let us go ahead and attach inside the cell. Right now, if I do Docker PS, we have two containers for Alpine, right? So Docker attach, and then let us do Docker Alpine 1. So now I'm inside the cell of the fall container. Yeah, ASS is actually the cell for the Alpine Linux. So that is why I used ASS. You could also use the simple ASS asset cell as well. All right. So that now I'm inside the cell of the Alpine 1 container, right? So let me clear this. Inside the Alpine 1 container, let me try to, let us open another window, right? Docker network, and then I will do inspect again. Breeze. I just want to show you, like for the Alpine 2, so you can see that we have the Alpine 1, and then IP for Alpine 1 is 172.17.0.5, right? And for IP for Alpine 2 is 172.17.6. So I'm just going to copy the IP of my second container, that is the Alpine 2 container. So I hope this is clear to you all. Alpine 2 container, and then from inside the first container, remember that I'm inside the first container cell. So if I try to ping, right? So ping -c 2 times. So I'll ping the container 2 times. So if I try to ping, then I do get a response, right? 2 packets were transmitted and 2 packets were received. So that means the container Alpine 1 is able to communicate with container Alpine 2 using the IP address of container 2, right? So that is possible in default Breeze network. So that is totally possible with default Breeze network. I could also ping google.com. I could also ping google.com, and you can see that my container is able to communicate with internet as well. So that is also fine, right? But if what happens if I try to ping by the name of the container? So the name of my container was Alpine 2, right? Ping dash C count is 2 times. So if I try to ping my container by the name of the container, which you remember, like if you go over here, that's going to be Docker PS. So the name of my container was Alpine 2, right? Alpine 2. If I try to ping it by the name, then I will not be able to connect, because by default, this is a very, very crucial point. Please remember, folks, that by default, in default breeze network, there is no possible way to communicate by using the name of the container. So there is no DNS resolution. That is the concept that is used to resolve the DNS name into IP address. So if google.com has some specific IP, right? So that process is called DNS resolution. So by default, in default breeze network, there is no way a container will be able to communicate with another container using the name of the container. But that is possible when we create our own breeze network, or a custom or a user defined breeze network. So that is what we are going to do now. So we saw that we are not able to create ping by using the name, and that is exactly what we are going to do now. So we are going to remove both the container. So let me just do docker rm. And by the way, you could remove multiple container at once using space, and then I'll do f to stop and then remove it. This will remove it forcefully. And then now let us go ahead and create a new network, right? So we are going to use docker network command and create, and the driver will be breeze because we want to create a breeze network, right? And we specify a name of the network, right? So this is going to be the default. I'm going to use Alpine Net itself. This is going to be the default, not the default. This is going to be a breeze network, but a custom breeze network because we are now creating it, right? So we created the network. We can verify it using docker network ls, and you can see that the network has been created. And right now, if I do docker network and then inspect and then Alpine Net, right? So if I inspect this right now, we don't have any containers, right? Because it's empty. We have not attached any containers to this network, right? So what I'm going to do is, again, I'm going to run two different container, Alpine one, but this time I'm using dash network flag and attaching it to the network that we just created, right? So again, we are using the Alpine image, which is a lightweight Linux distro, but this time I'm attaching it to a Alpine network that we created. So let's go ahead and do this. And again, I'm going to run another container, Alpine 2. So it is also going to be placed in the same Alpine net, because remember, if you don't specify the denser network and name of the network, it is always going to run in the default breeze and not the breeze network that we created, right? So now if I do docker inspect and then, sorry, not inspect, docker network inspect Alpine net, now you can see that it has two different containers, right? And the IP is 172.0.2 for Alpine 1 and 0.3 for Alpine 2. So let us go ahead and actually attach to the cell of Alpine 1. And if I do ping dash C two times, and now let us try to ping. So since I'm inside Alpine 1, right? So let us try to ping Alpine 2 from the name, right? So let us try to ping for the name. And here you can see that the connection is successful because we sent two packet and we received two packets as well. So this is the power of the custom breeze network. So please note that in custom breeze network, containers are able to communicate using the name itself, and that is really helpful when you are deploying microservices in production, because you don't always remember the IP of containers because they come and go quickly. So containers might die quickly, another container will spin up. So one container might go down and then you have another container spinning up. So the IPs are changing every time. So you want to have some sort of a DNS resolution. So usually you use the name of the container and the port where the application is running. So this is about the custom breeze network. I hope that was clear to you all. And that also concludes the basic part of our Docker network. And finally, we are going to cover the last part of today's section. So that's going to be the Docker storage section. I hope that was clear. Was it clear, folks? I hope that was. I know it might be a bit too much for some, but this is going to be, yeah. Yeah, the question is, yes, that's the purpose of creating a network, because you want a lot of containers within the same network to communicate with each other. So that is why we can attach multiple containers to a single network. Advantages of custom network. So I would rather rephrase these as advantages of custom breeze network over the default breeze network. Like I said, if you want to have there are two different purposes. So if you want to have DNS resolution by name, so that I just show you, so you could also connect to other container within the same custom breeze network by also using their name, right? But in default, it was only possible through the IP of the container. But in production, these IPs keep on changing, so you don't want to connect using IPs, right? So that is one reason we want custom breeze network, because we want to use DNS resolution by names of the container. Second reason is segregation. You don't want all the containers to be in the same default breeze network, because let's say you have like 500 or in production 100 different container or 50 different container within the same network, that will be too much polluted. And remember that if you are within the same network, then your any container can communicate with any other container using the IPs, right? So that is also insecure. So let's say I have different projects, 5 different projects, and each project uses 5 microservices. Then I just want to have these 5 containers communicating with each other. I don't want other 20 services to communicate to those containers, right? So in those cases, I want to have like 5 different network for my application. So normally we have a separate network for my front end container, for my back end container, and also for the other logging and the database container. We have separate network because we only want to ensure like there is a proper segregation of resources, and we also want to make sure that only certain containers within the same network can communicate. There are some advanced concept once you go into the world of containers. There are things like network policies, there are things like service mesh that makes these things a lot more easier to manage. But for now, just think of it in a way that you want to segregate the containers into different networks which are logically related to each other. So I hope that answers your question. Okay. So now let us talk about Docker storage type. So like I previously said, Docker by default, any container by default will only have a temporary storage. So earlier I showed you, I executed inside one of the Nginx container and I created the hello.txt file, right? But if I remove that container and then start the Nginx container again, that file will not be there because it was in a temporary storage, and Docker will discard that. So every time I run a new container, although it is from the same image, the data will be gone, right? So the data will be gone and it will not be persisted. So Docker by default, if you don't specify any storage options, the data will not be persisted. And that is why in cases where we want the data to be persisted, so think of it example as a database, right? If you have a MySQL database or a MongoDB database which is running as a container, then you would want your container or the data in the database to be persisted, right? You don't want it to go, or you don't want it to be lost when you restart a container or when you create a new container from the same image, right? You don't want that. You want the data to be persisted for a long time. And that is where the Docker storage options comes into play. And there are basically three different options. So the first one is actually the best one as well, I would say. So the first one is the Docker volume, right? So what you do is that you create a specific uh, area. So you have a dedicated area in your host. So let's say in my Linux machine, I have a dedicated area. So it could be /var/lib/docker. So that is a area or a repository path or a folder path which is only reserved to be changed by the Linux process and nothing else. So you could say that any containers, whatever container I want, I will create a volume for that container, and then those data will be kept inside that specific path. So that is one way of doing things, and that is actually the best way as well to persist your data. That will be Docker volumes. So it will be stored in your host system, in your own PC or a server or wherever you want, but it will be kept in a dedicated path which is managed by the Docker, where the Docker engine has the full access to read and write from, right? It will not be stored in a random path, let's say /user/data, or in case of Windows /d drive or e drive. It will not be like that. It will be in a very specific path which where the Docker has access to. Another option is bind mount, and bind mount is used to mount basically just say that you can mount any path. So here we don't have any restriction like it has to be in a dedicated path in the host machine. You could mount any path or a directory in the host to any part or a directory in the container. So let's say that I want to mount /desktop of my PC, of my own PC, to /data inside the container. So even inside the container, there will be the file system, right? Because it is using Linux ultimately inside the container as well. We'll talk about how the layers works in the second part when we see the demo of Docker images and how we can build our own. We'll learn more about that. But for now, understand that there is also a file system and a Linux process running inside a container. So let's say I want to mount /desktop of my PC to /data. So if I do that, so any files that I keep in /desktop will also be accessible by the container. And if I create a new file inside a container in /data, I will also see that file in my own desktop. So that is basically mounting or creating a shortcut. You can think of it in that way. And finally, we have the TMP-FS mount. So these are again the specific data points or specific records that you want to access in a very high speed manner. So if you have a very data intensive application, like very if demanding in terms of IO speeds, if you want to access it very fast or write it very fast, but only for a temporary period of time, then you can use the TMPFS mount, and it is will be stored in the RAM of your PC and not the hard drive or the SSD, but the RAM, because RAM is much more faster than the SSDs and all those things. So that is why we store in the TMPFS mount, right? But if you want persistent storage, then the Docker volume is the best way. Host bind mount is also persistent, but if you, let's say, delete the directory in the host where that was stored, then it's gone. But for Docker volume, it is stored in a dedicated path, so there are some additional security measures. So it's just the best way. All right. Like I said, volumes are stored in a part of the host system, which is managed by the Docker. So often in case of Linux, that will be /var/sleep/docker/volumes, and then whatever the name of the volume that you create. So your data will be stored inside this specific directory. If you don't specify a name of your volume, then it will create a random hash, and that will be the name of your folder where the data will be stored. And Docker, like I said, are the best way to store time. So now let us go to the demo of Docker storage and see all of this in action. Let me pull up my terminal. Okay, let me clear this up. Again, like I said, all of the instruction that I have given is already there in the official Notion that I've created for this demo. So please follow the Notion as well. Okay, so let us first try to list the volume. So I can use the Docker volume ls command, and you can see that I have already some volumes, and some are like random strings. So like I said, these are the unnamed volumes because I did not specify a name. So Docker created a random string of hash for the volumes, but I also do have like 3 named volumes. So one is for Minikube, which is used to run Kubernetes in a local environment. So you don't need to worry about that. Just remember that these are the 3 different volumes that I have in a named way, right? So let us go ahead and actually create a new volume. So I will create a new volume. So that's going to be Docker volume command, and then create, and then whatever the name that you want. So that's going to be my volume in this case. And if you want to get more details about the volume, you can use the Docker inspect command, Docker volume inspect, and then the name of the volume. You can see that you can see exactly the path where it is mounted. Like I said, it will be mounted to /var/sleep/docker/volumes, and then this is the name of the volume, and under /data will is actually where my data will be stored once I create anything, right? So I had created a volume, right? But how do you actually use this volume? That's the bigger question, right? So let's go ahead and do that. So I'm running an Nginx container again, right? But this time I'm also -d by now, you should also be clear. It is running in a dtask mode, and -v specifies the volume. And I have specified that it should use the my volume, which I already created just now. And then it should be mounted to you separate by a colon, and then you should specify the mount path where you want to mount this volume inside the container. So that's going to be /data, and then that's going to be where. So basically this path in the host will be mounted to /data inside the container. There is actually a better verbose way to do this that will be more clear. I will just quickly copy that from the Notion. So if you can also run the same instruction, but this is a more clearer way to do that. Again, run is same thing, dash test name. So we specify the name of the container. In this case, that's going to be a dev test, and then dash test mount. So you specify source. The source is going to be my volume, which was already created previously, and the target will be /data. So that's going to be the target inside the container where this will be mounted, and then Nginx, which is the name of the container. So the container is now created. So you can see that the container is already up and running, right? So what I'm going to do is I'm going to, let's say, run this command inside the container, right? Just a second. Okay, so I'm going to run this command, and let us try to see what this command does, right? So docker exec-it, I already told about this. It is used to execute some commands inside a container, right? So this is the name of the container, dev test. You can see that the name of the container is dev test, and I'm using bash, which is used to run instruction in bash shell. And then the command is I'm trying to basically echo this inside /data/hello.txt. So what this will do is this will create a hello.txt file in /data folder inside a container, and it will add this text in that file. So that is what this command will do. So if I do OK, then now let us try to confirm this, right? So if I do -it and dev test, right? So if I do /bin/ss, right? So now I'm inside the cell. So if let's go to cd/data, And if I do ls, then you can see that we have the hello.txt file right over here, right? So ls hello.txt, and then if I do hello.txt, if I do cat hello.txt, you can see that the text is also over here. So this means that this file is created, right? So docker ps, the container is running, the file was also created. But how do we know that the data is persisted, right? So what we are going to do is we are going to completely uh, let's say remove the container. So now the container is not there. So earlier I said that if we remove the container, the data would have gone, right? So data will not be there. But now, since we have when we created the container, we attach it to the volume, right? So let us create a new container, and this time it's going to be new test instead of a dev test. But remember that it is using the same source, the same my volume, right? So and the target is still slash data. So even though this is a completely brand new container, since it is using the same source volume, it should be able to have access to my data, right? So if I do docker exec-it, instead of a dep test, let me do new test, right? So now I'm inside the cell of a newly built container. Please note that this is a brand new container, a completely different container than the previous one, but we are using the same volume, right? And we are mounting it to a same directory. So if I go to cd/data, if I do ls, here you can also see that we have hello.txt, and this was created from another container using docker volume. So if I do cat hello.txt, you can see that the file is also here. So this is how you can actually persist data in docker, and I hope this helps, and I hope that proves the case as well. So that is how you can persist data in docker. I know this can be a lot of things, but please follow the notion page that I have provided to you all, and that's gonna be helpful. So now we have reached to the end of the session, right? So we have reached to the end of the session. So if you have any questions, then I'm up for it. Else I'll see you in the part 2 and the part 3, where we will actually deploy the we'll create the docker files, and we will build our own application emails. So until now we are just using the public images, but now we will create our own application images, and then we will deploy it to Azure container environment. Please make sure to check in for this event if you already have not. So for this event, you can still check in, right? We do have some time. So if you have not, then not that one. Just let me refresh this. Yeah, so that's one. So please check into the event if you already have not, and also please register for part 2 and then part 3, which we are going to cover today. All right. So the first question is, what is drive in volume? I am not sure what I understand your questions. Can you please rephrase the question, because I do not get like your questions. Do you mean the driver? So these are all the, since all of these volumes are stored in my host machine, so those are the local driver. But you could also attach, let's say, a network driver, network file storage like NFS, with things like Amazon EFS and all those things. We have different network files. Um, you could have the file system in the remote server, and you could also attach that to your own PC as well. So in that case, the driver would not be local and NFS instead. So I think I hope that answers your question, but please. Okay, so the question is, we can access data in container, not in volume. Yes, but those will only be temporary. So I showed you that we can docker ps. So you can, let's say that I am docker attach new test, right? Docker, let's exec docker attach alpine 1, right? So Alpine. So let's say I'm inside Alpine 2 right now, and I could see all this data. I could write this to this container. I could do whatever I want, right? But since Alpine 2 is not attached to any volume, right? So everything that I do here, once I exit the container and once I stop or remove the container, if I want to create it again, that data will be gone. So yes, you can access the data in the container which is not in volume, but if you want it to persist, if you want it to be there forever, then you need to mount it to a volume. And whenever you create a new container, or whenever you want to start a new container, you need to make sure that it is mounted to the same volume, and that way you get access to the container, the access to the file systems. Thank you for the compliment. I hope you all enjoyed the session. From yes, we do have one more question. Do we need to have this command execute in the cell? Yes, all of these, whatever I have done this now, it's those are all the Docker commands, and these are executed in the terminal or the command prompt if you are using Windows or PowerShell. So you need to be in a cell environment. Yeah. So that is about the for Docker volume. Do we need to have this command execute? Yeah, thank you for the compliment, defendant. Do we need to have for Docker volume? Uh, in order to attach the volume, no, you don't need to go inside the cell and then you need to manually edit the files or you need to add the files. That was just for the demonstration purpose. Normally, I'll tell you what happens in production. Yes, and I hope that will make things clear. You just need to run the appropriate command to create the Docker volume, and whenever you run a container, you need to attach that container to the volume that you have just created. So that is all you need to do from the cell. You don't need to execute inside the container, and then you need to create files, and then you need to remove files. You need to don't need to touch ls cd, nothing of that. What usually happens in production is that your application usually uses a specific path to add your data. So let's say your MongoDB database uses a path in Linux. So it could be /var/leaf/mongodb, and that is the path where Mongo will store all its database content, right? For SQLite, it's going to be similar. It's going to use a single path, right? So every application or API or any process that needs to have data persistent, it will write those data in a very specific path in a Linux file system normally, right? So that will be inside your container. But what you want is that you don't want that data to go. So that is why what you do is that you mount that path, the path where the Mongo or your container will write the data. So usually you will find this information in the official Docker Hub repo or the documentation of the image that you are going to use. So if you're using Mongo, it might write in a different path, or if you're using SQL, then it might write the data in a separate path, right? So you need to mount that path to a volume in your host. Your volume, you can create a volume. It will be inside /var/sleep/docker and then the name of the volume that you create. So that will always be in your host system. But the path where you want to mount to depends on the type of container that you are using. So not always you will mount it to /data. So for this, it was just a demonstration that you could how you could persist the data. But for actual production environment, you will know the path where you want to mount your volume, and in that way, whenever you run another container, and you can just attach the same volume, so it will be mounted to the same path and you will have access to that part. In that way, the Mongo or any other container that needs to write data will be able to access that path. And I hope this makes this clear. Yes. All right, so then we have come to the end, folks. Let us have thank you for attending the session. And also just quickly before that, just wanted to show you the schedule. So please make sure that you are also registered for the part 2 and 3, which we are going to cover tomorrow. So here we have the part 2, and also tomorrow we also have a mini event, and also the day after tomorrow we are going to have a part 3 that will be covered by me. So I hope to see you there as well. Thank you everyone. Specify using cell the files, we don't have to write it, right? So after we specify the path using the cell, the files will be written, and yeah, you don't need to write. The files will be written, and this need to be this path will be accessed by the APIs or the process within your container, and you don't need to write anything manually. That will be done by the processes within your container. So you need to have the process that you needs to utilize those paths, and it will be written. You don't do anything by yourself. All right, bye bye folks. I hope that concludes the session for today, and I hope to see you all again. Thank you everyone. Bye bye. Bye bye everyone. Bye bye. Thanks everyone.